Hello friends, good morning. Today we will see about the transistor load line analysis. In that we will see about DC load line and the Q point. But what is the transistor load line analysis? The mainly definition of this is that the load line analysis of a transistor means for the given value of collector emitter voltage we find the value of collector current. This can be done by plotting the output characteristic and then determine the collector current IC with respect to collector emitter voltage VCE. The load line analysis can easily be obtained by determining the output characteristics of the load line analysis method. Now we will see the DC load line. What we will see? We will see the DC load line. Okay, for that you have to consider this figure. Okay, which type of transistor is this? It is a NPN transistor. So you have to consider first the NPN transistor and draw the circuit like this. Okay, now what you have to do? You have to plot the characteristic and or you can say that DC load line curve of this circuit. You have to plot the DC load line curve of this circuit. Then how can you plot it? You can plot it like this. Okay, so what over here? It is the IC, that is the collector current in terms of milliampere. And what next? What over here? It is VCE in terms of volts. Now, I hope you have gone through the common base characteristics, common emitter characteristics, common collector characteristics. In that, you repeatedly you find a curve like this. Like this, like this, like this, like this, and like this. Suppose if I start, this curve is mainly due to IB is equals to 0. This one is IB1, IB2, IB3 and IB4 and IB4. Now what is DC load line? First, before going to the explained concept, what is DC load line? There is one point over this y-axis, there is one point over this x-axis, and you have to connect that 2 points, and whatever line you find, that line is known as the DC load line. Suppose if I assume the point A is over here, this point A is over here, and if I assume this point B is over here, and if I assume this point B is over here. Now what I have to do? I have to connect these 2 points, and whatever line I get, and that line is known as the DC load line. One more thing, before I told you that there is a Q point, and that Q point is present over this DC load line. Now how can you derive the equations? Okay, for that you have to apply the KVL at the collector side. Okay, what is the collector side over here? This one is the collector side, this one is the base side, this one is the emitter side. But what is this? VCE. So this surely emitter is present over here, but it is combination with the collector. So this whole side is known as the collector side. Now you have to apply the KVL on this side. So what is the definition? That is the VCC, that is the VCC. What is next? That is minus ICRC minus VCE. VCC minus ICRC minus VCE is equals to what? 0. Now what you have to do? You have to make this, or you have to make the subject to the VCE. So therefore VC is equals to what? VC is equals to what? That is VCC minus ICRC. VCC minus ICRC. Now in this equation, that is equation number 1, in this equation, that is equation number 1, the VCC and RC are the constant value. Why it is a constant value? Because this VCC is a fixed voltage source and that RC is a fixed resistor. So the value of these two components are fixed. That is the constant. Now, and it is a first degree equation. Due to these two values are constant, that's why it is known as the first degree equation. Now, the input characteristic is used to determine the locus of VCC and IC. For the given value of RC, we have to consider or we have to discuss the following points. The point number 1 is that the collector emitter voltage VC is maximum. The collector emitter voltage VC is maximum when the collector emitter voltage VCE is equals to 0. When the collector emitter voltage VCE is 0, at that time your the collector emitter voltage VC is maximum when the collector, there is my mistake before. The collector emitter voltage is maximum when your IC is equals to 0. Then what your equation becomes? Put this value is 0. Therefore VCE is equals to what? VCC. So this one is what? VCE maximum. Okay. Now next, the point number 2. Your collector current IC becomes maximum. When it becomes maximum? When your collector emitter voltage is 0. So put VC is equals to 0 in equation 1. Therefore 0 is equals to what? VCC minus ICRC. Therefore IC is equals to what? VCC by RC. So this one is the maximum. This gives the collector current axis on shown in figure. Okay. So what this point is indicated as? This point is indicated as VCC by RC. Clear? Okay. Now there is no such difference between AC line. If I draw about AC load line, like this, then whatever the intersection point between the DC load line and AC load line is known as the Q point. So which point it comes? That the Q point of AC load line and the Q point of DC load line both are same. The Q point for AC load line and the Q point for DC load line is same. So now what is Q point? That Q point is the operating point of your transistor. Mainly your transistor works as an amplifier. Okay, so if you want that your transistor works properly, then that proper work of transistor is mainly depends on this Q point. Okay, and this Q point is generally referred as quiescent point. This Q point is generally referred as quiescent point. Okay, thank you. So this is about the load line analysis. If you have any query, then you can contact me. Thank you.